asked to solve algebraically cos x sine 2x minus sine 2 sine x equals -2. Well, the first thing we have to do in this case is we have an x and a 2x, and we have to resolve that. So either we change x's to 2x's or 2x to 1x. And it's going to be much easier to convert the sine 2x over here into 2 sine x cos x with this identity. So our first step then is we're going to take cos x, and the sine 2x that we have here, we're going to replace with 2 sine x cos x minus 2 sine x equals -2. Okay, so I'm going to factor out the 2 sine x, so 2 sine x, and we end up with cos squared x. Okay, so cos times cos gives me the cos squared, and I have -1 when I factor out the 2 sine x out of there, and that's going to give me -2. So I want to factor this to see what pieces I'm dealing with, and when I factor this, I've now generated my Pythagorean identity. Now I have to switch that around, so I'm going to factor the negative out, and I end up with 1 minus sine squared x over here. So 1 minus cos squared, and that's equal to -2. I'm going to cancel the two negatives out, divide by -2 on both sides, so I get sine x, and this is going to convert to being the Pythagorean identity sine cubed x. Sorry, sine squared first, and it's going to end up being sine cubed. And when I do divide -2 by -2, I get 1 on this side, so sorry, that should be squared. Okay, so when I resolve this side, it's going to be sine cubed x equals 1. Cube rooting both sides, I get sine x equals 1. Sine x is equal to 1 only at 90 degrees, so x is equal to pi over 2. It doesn't domain over all real numbers means I need to do the repetition, so it's going to repeat itself. I have to go around the whole circle till I get another solution again, so it's going to be n2 pi, and again n is an element of integers.